In the previous lecture, we have discussed about the DMA functions, malloc, calloc, realloc, and free. And today we will continue with the same difference between static memory allocation and dynamic memory allocation. In static memory allocation, memory once allocated, it will be fixed, and in DMA, it can be changed using the realloc function that you know. It is not possible to resize the memory after initial allocation. Memory can be minimized or maximized using the realloc. It is easy to implement and use. It is complex to implement and use. Execution is faster, execution is slower. After initial allocation, the unused memory cannot be spared for utilized by other. Here, the difference is you can free some of the unutilized memory and it can be used by some other variables or some other nodes. Assignment is using first in, first out. There is no specific order of assignment because it is DMA. Wherever there is a free memory, it will be allocated. Array and dealing with list. List refers to a set of items that are organized sequentially. That is called list. Array is a derived data type to prepare a list in C. In array, the sequential organization is provided implicitly by its index. So we know that in array we can store the data and they will be referred by the index starting from 0 to n. All the elements are accessed and manipulated using the index. Suppose you want to access the first element, then you will use the index 0, and you want to access the second element, then you will use the index 1. What are the major drawbacks of array being a static memory allocation? Once the array size must be specified at the beginning, so this leads to inefficient memory utilization. Modifying size of array at runtime is not possible, so this will sometime waste our memory, or sometime we have the shortage of memory. If we want to use more elements, then we cannot use, so we will face the shortage of memory. On the other hand, if you consider linked lists, then they are completely different way to represent a list to store the data in form of structure. Each item in the list is part of structure that additionally contains a link to the identical structure containing the next item, and it is sometimes called self-referential structure. Each data in your linked list will be stored as structure, and each data will have a pointer or a link to the next data item, and this will have a pointer to the next data item, that is structure 3. So this way you will have a link. This type of list is called a linked list because it is a list in which order of items is given by the link from one item to the next. Each structure element in a linked list is referred as a node. So this we will call as a one node, node 2 and node 3. Linked list will be called as a node. So it will be a structure node. It will have first the item. Item is nothing but it is a data part where we will store the complete data. Here we have taken only one integer member but you can take more complex data like student name, roll number, ID number, marks, everything. The essential part, that is the second part, will be a pointer to the next node. So that will be your struct node pointer because it is pointing to the similar kind of structure. So it will be the struct node pointer. The name of the variable is next. And here is the end of structure. So you will have a struct node which will have integer item and a pointer next. Additionally, you can have a different structure like this: struct link underscore list, that is a linked list. Structure name is linked list. Integer ID, name, age, and then a pointer to the next node. So this will be your data part, item part, and this will be your pointer to the next link. In general way, you can write your struct tag name here, number of data items here, and the pointer to the next link here. If you see the linked list example, then this is considering the same definition. If this is your node 1, then node 1 item value is 10, and node 1 dot next means this pointer will have the address of node 2. So assume the address of node 1 is 5000, address of node 2 is 7008, then node 1 dot next will have the address of the second node, that is 7008. So we will store here 7008, and this node 2 dot next will point to the address of node 3. So each node will point to the address of the next node. All list nodes needs to be allotted in continuous memory space. All list nodes need not to be allotted in continuous memory space, as it is a DMA. It is following a dynamic memory allocation concept. So memory allocated for each node may or may not be continuous, unlike arrays. Linked list. In array, the last item is always represented as the index size -1. Similarly, no list goes on forever. That must be an end of linked list. So how to represent the end of the linked list? So we will use a null value in the next field of the last node. So if we go like this, node 1 next will have the address of node 2. Node 2 next pointer will have the address of node 3. Node 3 will have the address of node 4, node 5, node 6. Suppose the node 6 is the last node, then we will store null value in the next pointer of the node. See the example here. This node next value is 7008, means this is pointing to the next node, and that is available at 7008. Suppose this is being the last node, then in the next value of this node we will store 0 or null, which indicates that this is being the last node. No further nodes are available. This is the end of linked list. Linked list advantages and disadvantages. Advantage of linked list: straight away comparing it with array. Here is one integer array given, and the elements are stored 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose we want to insert one new element 11 at this place. Okay, I don't want to replace 2 with 11, but I want to insert 11 here. So each value, each element in this array should be shifted towards right. Then we can insert 11 here. So each element will be shifted right, and then we can insert 11 here. So to insert one element in array, we need to shift many of the or all the elements. So after shifting, this is your array. Now suppose you want to delete this element from again the same array. So we need to bring back this 2 here, this 3 here, 4 here, and so on. So again we need to shift all the elements in this case. So we are using array or linked list to store the data, to store the list, and in practical examples this list will be comprising of lakhs and lakhs of data. Suppose you are storing the data of people available in a city. Okay, you are storing their name, age, address, and all the details of lakhs of peoples. In that case, if you want to add one more person, then you cannot shift all the elements. It will be cumbersome, it will take too much time. So in array, this is cumbersome job. So this is a disadvantage of array. Now let us see how it is a advantage, or how we can do easily the same thing with the case of linked list. In linked list, you know that each node, the memory for each node will be allocated dynamically, so it will have its own address. So this memory is having the address 2046, this node is having the address 5048, and this node is having the address 9002. They do not need to be in consecutive order because they are allocated dynamically. So node 1 will have the item value or the data value as 1, and the next pointer points to the second node which is having the item value or the data value 5. The second node points to the third node which is having the item value 8. Now suppose we want to insert a node, this 3. This is the new node that we want to insert between 1 and 5. So how we can do this? We just need to break this link here and connect this here, connect this here, and this way simply we can insert a node without disturbing the remaining node in the list. In case of array, we need to shift all the nodes. This is not required here. Similarly, when we want to delete a node from the linked list, this node, first node points to the second node, and we want to delete this node, so we can simply do this, break this link, and we make this node point to the third node, and this will be automatically deleted. Linked list is a dynamic data structure, therefore it can grow or shrink in size during the program execution. We can allocate memory for the node using malloc or calloc for adding the new node in the list. So when you want to allocate memory dynamically, let us take one example. Suppose you are calling for registration for a seminar. So at that time, you know that how many number of person, you don't know that how many number of person are going to register. So as and when a new person comes for registration, you want to store his name, his organization, and contact details, contact number. So whenever a new node or a requirement for a new node generation is created, you can use malloc or calloc, and you can allocate memory for that node, and you can insert that node in your list. When a new person comes, you again do the same process and you repeat. It does not waste memory space because it is not necessary to specify the number of nodes to be used in the list. As I said, we can allocate memory as and when the person comes. We allocate memory and we store the data. Memory for the list node can be allotted or can be free at a point of time during the program execution. While the program is running, you can allocate more memory or you can delete some of the unused memory if they are not required anymore. The list provides flexibility in allowing items to be rearranged efficiently. This we will discuss in brief detail how we can rearrange the data. In array, rearranging the element requires swapping of memory. We know that how we can rearrange the data in array by swapping the values, but the same thing we can do in linked list, but that we will see later. Now, what are the limitations of linked list? What are the disadvantages? Traversing in a list is little bit cumbersome and time consuming. In a linked list, you cannot go to intermediate node or some required node directly like in case of array. In array you can see that suppose you want to reach at the fifth element, you can just use the index. Okay, you can just use the index to reach at the fifth element. You will use the index 4, but that is not a case in linked list. If you want to reach at the fifth node, then you have to traverse from 1 to 2, 2 to 3, 3 to 4 and 4 to 5. That way you can go in the list. So traversing will be cumbersome, that again we will see in detail later on. Second, linked list will use more storage than an array with same number of items. Okay, so similarly if you want to store that, as I said one example, that you want to store the data of student registration. Okay, this example, you want to store the data of student registration, then if you use array of structures and you use linked list. So what is the difference? In linked list, each item node has an additional link field, additional pointer field. So definitely the linked list will occupy more storage memory. But you know that there are many advantages of linked list, so we can bear with this. Okay, now linked list illustration of insertion of node. Suppose this is a linked list, linear linked list, and you want to insert this node here in between the first and second, then you can just connect this pointer here and connect this pointer here. So now this node is inserted in the linear linked list. Suppose you want to delete a particular node, you want to delete this node, then you can break this link and just make this link point to this node. So this way you can easily delete this node. We have 4 types of linked list available: linear linked list or singly linked list, that is the one we have seen; circular linked list; linear plus the last node will have the address of first; two-way linear linked list, first and last node will have the pointer 0, the next node will be the second node, previous node, no previous node available, so it is 0. This for this node, previous node address is this, next node address is this. For this node, previous node address is this, no next node available, so it is 0. Two-way circular list, two-way linear plus circular. Here the next node will be the first node, and here the previous node will be this node, last node. So it is a two-way circular list.